Hey guys, so in this video, we can discuss Leetcode 708, where we need to insert a new node in the sorted circular linked list. So let's take a look at an example. Let's say we have 1, 3, 4 as a circular sorted linked list, where 1 goes to 3, 3 goes to 4, and 4 goes back to 1. And we want to insert a new node 2, and the 2 can be inserted in between 1 and 3, where 2 is smaller than 3 and larger than 1. So it will go, the new linked list will become like 1 pointing to 2, 2 pointing to 3, and 3 pointing to 4. And keep in mind that the head node can be any node in the linked list. In this case, the head node is 3, so it doesn't have to be the smallest node. It can be any node in the linked list. So in order to solve this problem, we need to discuss all the possible scenarios that we need to consider while solving the problem. So there are in total three scenarios, and I have outlined them here. So let's look at the first scenario where we have 5 pointing to 6, 6 pointing to 9, 9 pointing to 3, and we want to insert 7. So 7 is in between 6 and 9. So we can just insert it in after 6 and before 9. So this is the most common case where the insert value is in between some of the values in the linked list. So basically what we can do is like we can just travel through the linked list and we keep a record of the current value and the previous value. Let's say like current value is 6 and the previous value is 5 and the 7 is not within the range. And then we go to the next node where the current value is 9 and the previous value is 6 and the 7 is between 6 and 9. So we can insert 7 in between 6 and 9. So this is the case 1. And the second case is like we want to insert like either 1 or 10 in the linked list, where 1 is smaller than the smallest value in the linked list, or maybe we need to insert something like larger than the maximum value in the linked list. So we need to insert it into between 9 and 3. So here, like we still loop through the linked list and until we reach the case where the current node is smaller than the previous node, then we can know we reach the node where the linked list, we reach the node where the smallest node in the linked list. So, and then we can check if the new value is smaller than the smallest node or larger than the largest node. Then if this is the case, we can just insert it in between 9 and 3 so that it will become the newer, this node will become the new smallest node or the new largest node. So this is the second case we can encounter while looping through the linked list. And the last case we can encounter through inserting the new node will be like all the node will have the same value in the linked list. Like this case 555, and we want to insert a new value. So basically we can insert any position in the linked list. So how can we know like all the node values are the same? So basically we just keep looping through the linked list until we reach the current node, which is the same as the head. So like let's say the previous node is this one and the current node is here, right? So we just keep looping until like we have the previous node is here and the current node is here. So then we can know like we finished one entire cycle in the linked list. So and we don't find any conditions meets like case 1 or case 2, then we know like all the node has the same value and we can insert a new value anywhere we want. So we can just insert a node like where we stop. All right, so basically these are all the three cases we can encounter while solving this problem. So let's try to code it out. Okay, so first we can consider an edge case where there's no head node. So if not head, if the head doesn't exist, then what we can do is like we can just create a new node. So the node has two input parameters, the value and the next node. So in this case, there's no next node because there's no head. So the new node will point into itself. So we can just like say and make the next node as none, and then the new node point into itself. We return the new node. All right, and now we need to consider the three cases we discussed above. So let's just try to define the current node, the previous node. The parent node would be head. Previous node would equal to the head. So while current doesn't equal to head, then we need to consider, we can just do the loop first. So the previous node would equals to prev dot next, and the current node just equal to current dot next. So basically, let's try to loop on through on the linked list. So let's consider case one. If prev dot val is less than or equal to insert val, and the less than or equal to current val, then we just need to insert the new node. Okay, so we can just say prev dot next equals to the new node, and make it pointing to the current node. And we can just return head. Right. And now we need to consider the second case. Where if prev dot val is larger than the current val. So this is like we reach the smallest value and the largest value in the linked list. So let's see if insert val is larger than the smallest value, larger than equal to the larger than equal to the largest value, which is the previous one, or insert val is smaller than or equal to the smallest value, which is the current one. Then we can just insert it. Just do this. All right, it's the second case. Now we need to consider the third case. The third case is like when we break out the loop, we reach the end of the, we finish the one complete circle in the linked list. Then we know like we just need to insert it here. All right, let's see how it goes. Looks good, and let's see. Yeah, works fine. So the time complexity for this would be order of n. Basically, we loop through the entire list one time, and the space complexity will be constant because we only have two identifiers, one for the previous node and one for the current node. All right, so this is the end of the video, and I'll see you guys in the next one.